how do I introduce myself? Well, I guess I work in a variety of different archaeological fields. My background was in initially ancient history, and then I came from Oxford to London to do archaeology and fell in love with it like everyone else, and then started to focus on Aegean and Mediterranean studies. But alongside that, I've had a really strong interest in spatial analysis and geographic information systems and spatial modeling and those kinds of topics. And that's quite a parasitic aspect of archaeology, a dilettante aspect of archaeology. So that means that you can do a lot of work in different fields. So I've also worked a lot in China and Central America and other parts of the Mediterranean on different kinds of modeling topics. And I've also got a strong interest in material culture. So my PhD was on stone vessels in the Mediterranean and value systems associated with stone vessels. So if you get a sense of that kind of slightly bric-a-brac approach today, that's the the background to it. I wanted to talk about things that could be used loosely called model-based approaches in the Mediterranean today, and talk about them with respect to a wide variety of different phenomena that you get in the Mediterranean in the past and present. You'll see that sort of part of my interest comes up to close to the present day. It's to do with landscapes, it's to do with cultural interactions, material culture traditions, but I think there's a little bit of a thread running through it nonetheless. So the things I want to talk about were, first of all, just evoke some of the current context in terms of data analysis in archaeology, within and beyond the Mediterranean, from the perspective of if you want to do modeling, digital modeling, statistical modeling, data-centric approaches, data-based approaches to archaeology. What are the current circumstances? I'd argue that it's undeniably a particularly fun period to do that kind of work right now, for a variety of reasons. I want to also look at Mediterranean micro-landscapes. It's something I've focused on quite a lot from a fieldwork perspective. It's something that you can model very effectively these days. And then look at the bigger picture, large-scale landscapes, large-scale artifact and settlement distributions, and longitudinal, that is long-term, chronologically long-term artifact traditions within the Mediterranean. So I don't know whether any of you have come across the fancy terms that are used outside of archaeology to describe the world we live in as being full of data now. Social networking data, data from mobile phones, etc., etc. We don't really face necessarily the same issue in archaeology. Outside of archaeology, people say that's such enormous amounts of data, big data as they call it, that we struggle to actually even store it. We struggle to process it, and we certainly struggle to analyze it. In archaeology, we don't necessarily have as much data, but I think it's pretty unusual. In the last few years, we're just getting more and more and more. And it's partly to do with the fact that everyone creates good data sets these days, and they circulate like a kind of gift exchange mechanism between colleagues. Slightly under the radar, and it's not necessarily formal, but people will pass on, for example, Excel documents or lists of things. It happens in a sort of serendipitous fashion. Also, various kinds of collection routine make the evidence that we collect these days far faster on a bigger scale. You could think of the way in which something like terrestrial geophysical prospection, magnetometry, resistivity, ground-penetrating radar, they have now become techniques that produce a lot of data and no longer just look at one site. They tend to look at big landscapes now, particularly in Northern Europe, but also in the Mediterranean. So large-scale coverage. You've got various techniques which I'll briefly mention that produce open access data sets of various sorts. So just by way of introduction, that's an unusual climate. It's not the same as a decade ago. And I think it means that there are changes in terms of the way, for example, we would teach archaeology, and there's certainly changes in the way that people might do doctoral dissertations or postdocs or research projects. It modifies the way we'd operate. Here's a good example, slightly off topic, but remote sensing revolutions. Staggering the way in which everyone now uses Google Earth as part of their work. We have satellite imagery and aerial imagery that's not just high resolution in terms of spatial resolution, but it stacks images. It's what spectral depth, as they call it. So you can look at things in different parts of the visible and non-visible part of the electromagnetic spectrum. So fancy ways of looking at prospecting for archaeological sites, for example. We have aerial photos back to the First World War that we can use within the Mediterranean if we like. We have World War II aerial photos for the Mediterranean, of very high quality, and several other series thereafter. So you can talk about looking at those in sequences for landscape change. I already mentioned the geophysics aspect. A lot of other data sets, like LiDAR data sets, that produce vast amounts of information. So just in one portion of archaeological science, that's the explosion in the last half decade. And I'd argue, I'm not going to do it today, but I'd argue there's similar explosions in other aspects of archaeology as well. We need to be a bit prepared for that, really. Here's one last one. You may or may not have come across this, but you might say the rise of the digital photo. Digital photos today create three-dimensional models, if you take enough of them and you process them correctly. And that's going to, and is starting to revolutionize almost every aspect of archaeological recording you could think of. Whether you want to model terracotta warriors on your right-hand side there in 3D, just by taking photographs of them and then look at their shapes, or you want to look at landscapes, bottom right, or you want to model standing buildings, your top left, you just take digital photos now and model the overlaps. It's a method called structure from motion, or 3D photogrammetry, or computer vision as terms. So very interesting. But lastly, really just to focus on data access. Some of you may or may not know that there's a trend towards open access in journals. That's probably the most commonly recognized background. There's also a trend towards people publishing their data in open fashions, which means if you produce a data set for an archaeological survey, you would publish it online under a use license which was freely available to everyone, an open license. Creative Commons is perhaps the most famous example. But this idea that some kinds of information are open for modeling, open for business, and others are still closed off or still kept close to the people, the researchers that create that data, that's a real political agenda in archaeology. So you tend to have to take a personal position on that in the next few years. And it has effects on what I want to talk about for the rest of today, which is about what modeling you can do of this kind of data. But underlying that is, who else can use that data? Can they repeat the modeling that you do? How scientifically transparent is it? And I'd say that in the last several decades, we have not been particularly transparent in terms of our provisions of data, and that's really held us back. How much time do I have, by the way? Send a dig out. Okay. I want to start with some small landscapes. In fact, I'm going to pick an extremely small landscape I worked on for a long time, Antikythera, which is as background, some early and formative experiences in Aegean archaeology for me were working on the Kythera Island project, which is directed by Cyprian Broodbank and Evangelia Kyriatsi, on the island of Kythera, between Crete and the Peloponnese, bottom left there. And that's still an ongoing project, produces all sorts of fun information. Thereafter, I had the chance with a colleague, James Connolly, and in collaboration with a member of the Greek Archaeological Service, Aris Saravopoulos, to work on a neighbouring island called Antikythera, which is the one sort of highlighted there. And we've just finally got shot of the last publication of that venture, which is that book there. So these should be, in theory, final results that I'm talking about. And all of those other people were heavily involved, and it was a really fun collaborative venture. Antikythera is a really odd place. it's an island that has a present-day population of 43 people, and it's got maybe an area of 20 square kilometers, so very, very small, tiny island. And it looks pretty barren as you pass it by, so those cliffs on the top left are very impressive things that you see in a passing ship. It's probably most famous for the Antikythera mechanism, Antikythera device, top right as you see it, which was an instrument found on a shipwreck 100 meters off the shore, and is probably some kind of astronomical device for looking at the movements of the planets, for example. It says more about passing ships, perhaps, in shipwrecks than it does about what's happening on the island. On the island, you just get a lot more goats than you get people. So there are 3,000 goats on the island and 43 people today, which is probably a ratio that's existed in the past as well. And for Buondelmonte in 1420, it was an island that had wild donkeys with healing properties, so not much has changed. And for a modern American writer, it's an island that's sort of got a James Bond-style Dr. No sort of romance. Actually, there are no beaches like that on the island. It's nowhere near quite that romantic. I said it's a funny place to pass by. Here's some brief modelling just to get things started. On the left, you've got a medieval map of the area, Western Crete, bottom right. Top left is Monemvasia and the tip of the Peloponnese. And in between, you've got Kythera, the big island, and Cecerigo, little island Antikythera. That map is there for a reason in the medieval sources. That's because it's a thoroughfare. All of the boats pass through one side or the other of those islands, and so all of the little reefs, all of the wind directions, the possible moorings, they're important for navigators in the medieval period. So people coming from Venice, for example, going to Constantinople or to the Levant and back again. It's also a place of great great piracy in the medieval period, so another good reason why they wanted extra information. For a sailor in 1822, a British sailor, that's the quick sketch that he did, bottom right. Again, a sort of rocky shore. You can model that with a GIS perspective by, for example, ringing the island in viewpoints in the sea that look at the land, and you get that cumulative viewshed top right, which is all of the areas in red. Very few places, a lot of places on the sea can see those locations. So the cliffs in red, very visible, is exactly what that midshipman can see bottom right. All the blue areas are the areas you can't see very well. And what that evokes is that, frankly, for any passerby, and you could think about all Northwest Europeans on their tours, for example, their grand tours back in the day, or all people on yachts even today, they wouldn't see the agricultural basins, for example. They would not see the interior, which is actually quite decent for such a small island. You could support a decent community on there. So it's a bit of a misleading island in that respect. Just to evoke some of the things that we were interested in when we did this study. Right up to the present day, there's a material culture of conflict, which you see, hand grenades and gun emplacements and buttons from naval uniforms and 19th century bayonets. So we were collecting material culture up to the present day and right back into the past. And the techniques we were starting with are the standard techniques that you get in archaeological survey, but of the intensive variety. So the idea that you systematically cover a landscape and collect surface information from that landscape using, for example, field walking techniques with people walking 15 meters apart and collecting finds, or returning to archaeological sites. So you can see bottom left, the red squares you can see on that sort of perspective view there, returned the grid collections from when we return to archaeological sites and collect them at greater detail. We were interested in the historical record and how you could model that as a proxy for what's happened in the past. And the thing that I really wanted to focus on here was, well, two things, two touches really. The first is, with a modern data set, you have things that you just cannot address in the same way in previous phases of an island's history. So you've got standing buildings, a lot of them. You've got field systems, all sorts of things that are just not available to you as forms of evidence in previous periods. So the challenge then becomes, how do you reconcile an understanding of the present day or the last 200 years, 300 years, with a very long record? How do you model those together? If you've ever asked somebody to draw the site that is the 19th century village in their local area, most archaeologists will find that very difficult. Archaeological sites are things that you have for periods in the past. When you get to the 19th century, you don't talk in archaeological sites, or people wouldn't know how to do it. And that mismatch, that exceptionalism of the present, that mismatch between what we do with our present day evidence and what we do with our past evidence is difficult for modelling. I'll come back to it in a bit. The other thing I wanted to say is that you've got this top left image, which you can't really see, is a picture from 1800 to the year 2000 of population. And all you really need to know is that it goes up and down very sharply. The island is recolonised in about 1785. It climbs to between 400 and 1,000 people on the island. And then it drops off, and now they're 43 again. And that little blip is potentially a model, a conceptual model, of what happens on that island repeatedly through time in the past. But you've got these potentially spiky, up and down, roller coaster style demographics through time. At least that's what we think. So I'll come back to that. We also did some environmental modelling of various sorts. So these are things that we try to create as open data sets. So they're freely downloadable from the UK's digital archive. So things like modern terrace systems, elevation models, those sorts of things. It's a variety of different interests we had there with collaborators on modelling the environment. One of the things I want to talk about quite a lot today is the issue of how we recognise and then get past all of the problems that we have with archaeological evidence. Problems to do with its unevenness, its patchiness, its uncertainty. Here's the first one. When you do an archaeological survey, top left is an image, a nice attempt to be fancy with archaeological survey data. So red is high density of surface pottery. Blue is low density of surface pottery across the island of 20 square kilometres. So one of the fun things about Antikythera that's fairly unique, I think, is that we covered it with these methods entirely. The whole island was covered with these methods. Normally, surveys are a little bit more patchy than that. So we can produce an image like that. But underneath it is the fact that the island has vegetation cover, bottom left, which is patchy. And there's strong statistical relationships between how much you can count, how much you can record, and vegetation. Where there's lots of vegetation, you don't record much archaeology. Where there's not much vegetation, it's easier to do survey. So that's not good if you want to do some modelling. You would prefer to get an even picture. But you don't get an even picture, you get an uneven picture. The other thing which people don't grapple with enough either in excavation or survey, but it's particularly bad in survey, is chronological uncertainty. So here's a typical periodization for a survey in the Aegean or Mediterranean, well, in the Aegean anyway. So you might not be able to read it, but you've got Neolithic phases and early Bronze Age phases, and it goes through to the Classical and Hellenistic and all the way through. Blocks of time that people try and recognise. Here's a typical survey find. Horrible, grotty amphora handle. And if you tell a specialist, help me date that piece, they may say something like that over Iraqi. They might say, possibly Hellenistic, more likely late Roman. I don't think it's in between those two dates. And that's a hopeless description to try and force fit into a database. It's not something you can do statistics with. You might then collapse it. This might go into the database. But even that's not very nice. Late Roman or late Roman question mark, or that's still not something that's very easy. We have tried playing with a probabilistic assessment, something like that, because probabilities are inherently more tractable. Don't want to get into the nerdy statistics too much, but the thing that I wanted to emphasize here is when you look at those numbers, those bottom numbers, say do it in a percentage confidence or a probabilities way, and then you look at different periods for a survey data set, you get a little bit depressed because some periods, say the bottom left one there, late Roman, you can date a lot of your sherds absolutely with certainty. You can say this sherd is definitely late Roman. That's definitely late Roman, can't be anything else, must be late Roman. Other sherds, you can't date with certainty. These ones up here, well, that's a tripod cooking pot leg in a courseware fabric. It's almost certainly Bronze Age, but who knows where within that it is. So if you're looking, say, is it neo-palatial or not? Is it sort of later mid-second millennium BC? 30% chance, 40% chance, who knows? But it's definitely not certain. So the key point here is simply when you do modelling, your periods, your comparisons are uneven. They are also uneven in excavation. People think that they get greater certainty with excavation. They do, but not that much greater certainty. So comparing a period like this, when most of your finds are poor quality information, with a period like the late Roman period, where your finds are good quality information, is really tricky. But very, very rare to see anyone even mention that in a publication. They just compare them as if they're the same. Anyway, with that sort of sense of worry in the background, so there are these problems we have to grapple with, there you can still pull out some good modelling data. I'm going to quickly skip through some sort of highlights of Antikythera and then get on to other things. We get an early lithic record, at least 5th millennium BC. These wonderful projectile points are particularly interesting. So later Neolithic, obsidian core. More obsidian on that island than you'd expect, given its neighbours. More obsidian density-wise than Kythera to the north. Certainly plenty more than a lot of Crete. Those projectiles, here we are, 30 kilometres off Crete. And if we look at those projectiles in particular, this is the distribution of those projectiles. All over the Aegean, none, as far as I know, on Crete. And 30 kilometres away, we have 40 of those on an island of 20 square kilometres, which is a really strange, counterintuitive thing. And that must mean that something odd is happening. And our argument is that these early phases must be visitations from Western Crete, Western Cyclades, Saronic Gulf, that sort of area, hunters probably of some kind or another. They certainly can't be a local phenomenon from Crete because the material culture is not the same. And Kythera, also, the material culture is not the same. And there's not much. You could look up to the western islands there, but there's not much else beyond that. So it really has to be visitation. And all the projectiles probably mean hunting of some kind. It could be the birds that migrate up and down that route. It could be that I don't think it is, but it could be even the whales that go along that Ionian Sea route from southern Crete up that way. It's probably more likely to be things like deer, hare, introduced goat maybe, that sort of thing. But interesting. Regardless of what it is, it's longer range hunters that start off this phenomenon. Thereafter, final Neolithic EB1, you get this sort of thing, which is a scatter, quite a small scatter, but a concentrated scatter, and lots of them across the island. So you get cheese pots, you get ladles, you get incurved bowls, you get all sorts of things that are probably from that period or possibly earlier in one or two cases. But they're now quite concentrated. So the question is, have they become permanent small settlements? We're not sure, but that question of permanence, when are people starting to settle, is an issue. And the material culture looks a bit more local. Here, this is a local source of this material. So maybe you're getting local exploitation by this phase. Late pre-palatial, in Cretan terms, proto-palatial, quite difficult to see on the island, and you could say that that is because it's not there, or it could be that we just don't have the diagnostic confidence, what I said before about whether you can recognize something or not. Maybe we just don't have that for that period. We don't have the right idea what we should be looking for. I'm not sure which one of those it is. But we can certainly say that there's a very strong neopalatial set of evidence. So neopalatial mid-2nd millennium BC. And we've got things like pithoi, and jars, and finewares, and beehives that sort of indicate that there's a sort of mixed economy on the island, loom weights. So little farmsteads, 20, 25 of them across this island. This 20 square kilometre island, you've got these tiny little farmsteads, probably small families. And they look like this spatially. So if you model them in a GIS and you pull out the different shapes, you get these tight clusters of data. This is about 50 by 50, 60 by 70, something like that in meters. This is a 50 by 50 square. So really very small scatters of pottery, probably a family. There's patterning in the data. You can find that the finewares are very clustered with the cooking pots in many instances. So you're getting some preservation, even on the surface, of functional suites as found in floor levels, for example. Certainly not perfect, very messy, but repeatedly you're getting some spatial patterning at that scale, which means that survey can, under the best conditions, produce a little bit of spatial data at that scale, tell you activity areas or where people are throwing rubbish, that sort of thing. But of course you have to be very, very cagey, you have to be very careful, because it's been ploughed since then, it's been destroyed, it's been reused, it's not straightforward. They're probably farming these sorts of things that you can see in the image. Little tongues of a quaternary alluvium, little small amounts of good farmland in channels that they can, for example, put little terraced plots in. It's an intensive form of agriculture, probably, along with some beekeeping maybe, and maybe some small-scale herding. Two interesting things about this landscape that I'll try to bring up again in a sort of more comparative sense, but they're really, really interesting. You've got a dispersed landscape of farms, and something similar is going on in Kythera. Here's a dispersed landscape on Kythera. All of the orange are these farms, every 500 meters, say. And in between are little tombs, red little tombs, little rock-cut tombs. It might be the edge of land holdings, for example, between those different farms. It's difficult to say. That's on Kythera. We have something similar in terms of the settlements on Antikythera. So nice spacing of maybe 300 meters there, something like that, between those two sites. But the funerary evidence, such as it is clustered. It's very, very tightly focused. It's a bunch of rock-cut features in the center of the island. A whole bunch of them here. They probably start quite early. There's a source boat, an early Bronze II source boat from the same area. And it's likely this is a cemetery area through the Bronze Age. So dispersed farmsteads, but a clustered funerary landscape. And the key point I haven't made yet is there's no city, no town on this island, which is very weird if you think about it in the Aegean. You'd expect an island to have a central focus. Certainly Kythera does. Kythera's got a big port town, Castries. And if you think about it in terms of protection, how do these people make sure that they're going to survive? They're not predated upon. There's no fortification, there's nothing else. So it must say something more broadly about the conditions of life in this part of the Aegean, that 20 farmsteads can survive repeatedly in this landscape. There's some Mycenaean period, so latest 2nd millennium BC finds from the island that suggest that that farmstead landscape continues sometime into what the ceramicists would call late Helladic, late Minoan 3A, possibly B. It's quite difficult to date, but certainly into that period to some degree. Thereafter, nothing. And we've looked very carefully, and we've looked for the kinds of finds that people have noted elsewhere. There is nothing obvious until about 325 BC. So you know I said that there's no Middle Minoan that's very obvious on the island, but it's hard to tell. We can be much more confident here that there's a big period of abandonment. After those farmsteads, they go, and nothing else happens until this town, a fortified Hellenistic town with big walls and fancy stuff and evidence of destruction by violence, so all sorts of weaponry, slingshot bolts, ballista bolts, arrowheads, all sorts of things, that is the next big phase of settlement. So you can already see that you could tell a story about a pretty rocky settlement history on the island. One of the reasons we want to pick those periods out in survey is because they're interesting separately, but they're more interesting looking at them comparatively. So I won't get into the heavy statistical mumbo-jumbo of these plots, But the point that we're trying to do here is two separate chronological periods. Compare them for their relative location in the landscape. So compare them to all of those environmental variables and say, is it the same strategy? Are people locating in the same places in the landscape? Or are they locating their settlements in different places? And the statistics, the reason it gets so heavy going is to try to make that comparison very tightly. What is different about two different phases of history on the island in terms of the priorities of the people living there? Sometimes they may be locating in the best farmland. In other periods, they're locating themselves in hidden places in the landscape. And that obviously reflects broader issues, what they're worried about most. So, to evoke the modelling that we're trying to do here, we think in later periods you can prove that you have this happening on Antikythera, which is very small scale activity of some kind or another in certain periods, which might simply be the odd flock of sheep or goat being located on the island. That's why it's called a goat island today. Its classical name is Egula, which is goat island as well. So it clearly had that role as a place where you station flocks. It's a classic Mediterranean strategy. In other periods, you get a sudden pulse of settlement, permanent settlement. And we think that there's one, for example, well, there's definitely one in the mid-2nd millennium BC. There's definitely one in the Hellenistic period. There's definitely one in 12th century AD. There's definitely one 18th, 19th century. So that roller coaster is what we think happens chronologically. As you go backwards, it's hard to say, isn't it? If you've got that chronological uncertainty, you could be tempted to make a smooth chart of settlement. But the alternative is, of course, the same things happening repeatedly. Two or three last things to say on that. And one is simply that when that's happening, you've got a wider world of interaction that's going on. Empires rising and falling in later periods. In earlier periods, at least various forms of trade and travel and connection. The material culture changes in really interesting ways, so that you get periods where you have an abundance of certain kinds of finds, and other periods where you get very few. Things that you might expect are missing. So we get, in some periods, we get 70%, 80% amphory in the finds assemblage, which is unusual, very, very unusual. We have those huge numbers of projectiles in the early periods. So material culture has these funny highs and lows itself, just as the settlement does. The settlement shape changes in dramatic ways. So we might guess a certain population in a period, but that doesn't tell us how it's arranged. And here are two periods where we think they have similar amounts of people, maybe 400, 500, 600 people living on the island. But the shape of that's the fine distribution from the 19th century AD on the left and the Hellenistic period on the right. So roughly same population, totally different way of living on the island. In the one, Hellenistic, it seems to be a pirate community. At least that's what the few historical records claim. Maybe they're just calling people names, but it's supposed to be a pirate community, and hence those fortifications, if you believe that story. In the 19th century, it's supposedly under the British administration, and you have a very different farmstead and village landscape. Last thing to point out is that it's what we call landscape persistence, which is there are lots of different places people have lived on this island, and that's created the grey areas, which are where you get consistent settlement of various periods. But the circled areas are the areas where people keep returning for no good reason particularly. It's not like there's anything particular about that location which is special. It's not a spring. It's not a particular geology. Those circled areas, they're repeatedly returned to because something's being created there which anchors people, even though there are periods of abandonment in between. So somebody lives there, there's a period of abandonment, and they return to that exact spot in the middle of a bunch of fields. And that's got to probably do with capital. So there's stone collections there, for example. There might even be the beginnings of a well or something. But very small scale things encourage persistent behavior at small scales. So that's a Mediterranean phenomenon to a T. That's exactly what happens. Above and beyond all of these big environmental deterministic features, you get these little human activity spots that encourage new ones, even after gaps. Okay. Right, the next thing I want to talk about is settlement distributions, but on a much bigger scale. You can do model comparisons these days at the continental scale, and that's quite interesting. I think it's the type of thing that could be done in the Mediterranean to useful effect. Here's just an example from Europe to give you a flavour of what I mean. You all come across the idea of culture history? This idea of drawing cultural boundaries around things and calling them cultures. It's a very strong European tradition of archaeology. Strengths and weaknesses like any other tradition. They produce culture atlases, this kind of technique. Polygons, effectively, that you can draw on a map that show you the central core of a culture, which is supposed to be like a historical hero, if you like, isn't it? A culture does something, it spreads or something happens to it. This atlas produced 8 phases for the Neolithic across Europe. If you stack them up, you get this, which is really weird. That's the stack of the 8 phases of the Neolithic, with dark red showing you where you get consistent polygons drawn on the map for the culture histories. And the grey areas, never a single polygon drawn in those areas. They're cultureless as places in the world. And that's got to say something either about our archaeological recovery again, how well we're identifying things, or that repeatedly those are the sort of persistent places where you get lots of population. It actually mapped beautifully onto, this is soils, Loess soils, the big European soil complex. So that and the dark areas of red there map well together. There are more stories you could tell about that, but the fact that we could be doing that sort of thing in the Mediterranean in a really coarse way, just to throw out some problems and some potential. I don't think it's saying telling us an easy story, though. There's some really cool things that people do in terms of modelling interaction these days. Networks are the big deal. This is probably the best paper around, I think, or one of the best. I'll show you the other one in a second. PNAS on Syrian early Bronze Age network arrangements. An amazing fossil landscape from the 3rd millennium BC, with not just the settlements, which are tell sites, big mounded tell sites in this area, but also evidence in the remote sensing data of hollow ways, of the routes between those settlements. If you've got that kind of data, you can do modelling for the rest of your life, which is probably what those two are going to do. If you've got historical data, you can do some pretty cool modelling too. So this is Doomsday Book population on your left. So the earliest census in Britain, sort of census tax records, 11th century AD, and you can model it against a big coin find distribution. And my point here, which I wanted to come back to later, is that any distribution of finds like this, in the Mediterranean or elsewhere, we have to think of as sitting on a population surface. This activity is on a population surface, different densities of underlying population. So you can see they map on very well with a few exceptions. Where you get lots of people, that's where all the coins are, obviously. But population has been a bad word in Mediterranean archaeology for some time. Nobody really talks about demographic estimates, but it's really important. Another thing is patterns of recovery. I already talked about this. This is a Kythera distribution that, if Kythera was bad as a study, if the Kythera Island project was a bad study, they would publish like this. But hopefully it's a good study, because they will publish, they will publish like this. The orange is where that survey actually surveyed. So if you look at the red distribution, that's what you see on 95% of distribution maps that you ever look at in archaeology. The underlying recovery is that. So obviously you can't say much unless you have that. Now you go to your sites and monuments record, which is what most people do their modelling from. You could go to the Belgian national record, you could go to the Dutch DANS record, you could go to all of those. Where is your map of the orange? It doesn't exist. I mean, it doesn't exist in England either. There's no concept, no way of mapping recovery. We don't know. The intensity of recording of finds across Britain or Belgium or wherever, that's been variable, and we don't know how variable. So it's a very difficult thing for the modelling process. Here's one way you can try and counter it, which is this is quite a statistically involved technique, so I won't go into too much detail. It's a model of the distribution of settlements, but it could be the model of anything, and it jointly models what they call first order effects, which are things like environmental variables, like these ones up here, and how they might affect the density of archaeological sites. So in the traditions of Belgium and the Netherlands and elsewhere, predictive modelling, this would be called. You take these underlying environmental surfaces and use them to predict where archaeological sites will be. What you can do in addition, but people don't do very often, is model the interaction between the sites. Here are 3 examples. So sites can be very clustered. We looked at that Hellenistic example where the whole population is clustered in one place, very nucleated. They can be very regular, like the farmsteads, spaced apart. Or, sorry, the other way around. They can be random, like that. Most of the time in archaeology, we never put those two together in a formal statistical sense, but they have to be modelled together, actually. Joint modelling of this and that is the way forward. So certainly it's something we're trying with Mediterranean data. I'll show you an example now. I've been very interested in political geography of Crete and other places for a while, so just to evoke it, a very interesting case on the fringes of the proto-literate world in the Bronze Age. So we have script, we can't read it. We have evidence for very complex elite societies, potentially courtly societies. We certainly have central courts. Are they, like in the Eastern Mediterranean, ruled by kings? And do they have sort of the standard, that standard character? Or are they something slightly odd, as a lot of people, including Andreessen, have pointed to some really strange behaviours that would force us to slightly step back from some of the standard models? I'm certainly not going to answer that. But I'd like to look at hierarchy of politics in Crete. So if you want to model this is our archaeological recovery at a really coarse scale of large sites and sites with palatial features in Crete in this period. So I've just made it a slightly cartoony palaces and non-palaces, and big sites that don't yet have palaces. If you want to say, how did that happen? What are the dynamics of the way that's evolved? Well, the red crosses here are the ones that we've got lots of information for. I've excluded smaller sites. But we know that that settlement landscape, the red crosses, is not the whole settlement landscape. We're missing a lot of the settlement landscape. We haven't uncovered it yet. I could have added more red crosses, but I thought I'd be conservative. That modelling I talked about allows you to take the pattern of the existing medium to large size sites and predict where they're likely to be elsewhere. So they're likely to be more on these flat areas, the yellow. They're not likely to be above, say, 1,000 meters or so. So you could exclude the top bits of the White Mountains, for example. And typical spacing of some of these medium sites is a certain distance. So you can say they're not likely to be next to each other if they're medium-sized sites. So the grey circles here are one example of a prediction of where you might find smallish, but not tiny, to medium-sized sites elsewhere. Take this, which is, you have no information yet except the locations of the real sites and a couple of and some predictions. And the idea is, can you predict that pattern? And actually you can to some degree. Oh, this was the other paper. These are the other papers that I think are great. Carl Knappett and colleagues, Tim Evans and Ray Rivers, have done some really interesting papers on interaction. But at a broader scale, the same period, looking at Crete and neighbouring interactions. And I'll come back to this technique that they're using is fairly similar to the one I'm going to talk about. It's one very much based on sort of entropy-style models of interaction between nodes in a sort of dynamic network. This is the model that we use, which was first introduced into archaeology a long, long time ago, actually, by Tracy Brill and Alan Wilson, but sort of disappeared from view for a bit. They used it to predict the rise of policies in the Peloponnese. So here's a sort of more modern re-rendering, where, again, with no more information than just the location of the points, the configuration of them suggests that certain areas will grow to be bigger, more important. They're sort of more nodal. Not assuming a network of interaction yet, just assuming sort of the distance-based interactions. We put a network on here, of course. These are a network of possible interaction routes where the darker ones are more interaction. But their model is called a spatial interaction model or an entropy maximizing model. If you take those predicted points on Crete and you run one of these models, here is the kind of hierarchy that you get, where the blue circles are so important that everything else drains into them locally. So you could call them sort of terminal sites, local centers. They are the head honcho site in that local region. And these are the sort of dependencies modeled by that mathematical procedure. So the other point, these are sort of dendritic networks to a central site. And this is one solution, and you can see it regionalizes in a slightly interesting way. It doesn't necessarily predict much yet. This one takes no account of off-island interactions. So that's just the kind of modeling you get for one solution, where you're assuming no off-island interaction. If you add in some interactions, you get something like this. You basically get the centers being dragged, in most cases, out to the coast a little bit. And that's I'll come back to it, that's a standard Mediterranean tension, you might call it. The tension of the agricultural interior, that the big sites want to be in the interior where the best farmland is, and the tension of getting coastal access, that port access is really important. And obviously, as you go towards the port, you're at risk of things like disease and piracy, and as you move inland, you're at risk of not connecting with the big trade routes. So that's a to and fro you see throughout Mediterranean history. So that's one way of trying to model it. You can sort of see that it's starting to model things that are a bit more plausible. You get these centers in roughly the right places. Maybe the sizes aren't correct, but they're plausibly marking regionalism on Crete. The thing that you can do with these models, which I cannot emphasize enough in terms of the thing I find coolest, is that with modern computing, I said that we predicted those grey circles here on the basis of the red crosses to fill the landscape. Doing that once is a bit of a nonsense, isn't it? You could probably get it wrong and it might have a different result. If you do that next time, you could get a different result. Because those points, they might be modeled to fall on the flat land more, but they could be anywhere on that flat land. The thing you can do nowadays, which is called Monte Carlo simulation, is iterate 100 times, 1,000 times, and then you get rid of some of the randomness, or you model it probabilistically. And that's what we've done in this case, for example. So these are one example result for those two. In this case, this one, with off-island interactions. On your left there is a summary of what you get if you do it 1,000 times. So the yellow areas there are repeatedly given a high hierarchy site in 1,000 runs. So they map on extremely well to palatial centers. So it's highly likely you'll always get regionally with that sort of configuration, with the background settlement pattern that you get in the Bronze Age, that you get centers in those places. And it's highly likely that you'll get frontier effects. It's not a very good map actually, but you get frontier effects in particular places on Crete repeatedly with that kind of configuration. So that's a kind of settlement modelling. I don't in any way think this, how do I say it, is an end solution at all. But it's a fun thing to play with because it does start predicting regional dynamics. And the other fun thing you can do with exactly the same model is not model it in terms of as the crow flies distances. So far, these sites have been interacting as if they're on an ice rink, effectively. Flat, frictionless travel. And of course, Crete is not frictionless. Crete is a big, rugged place. So you can add in topography, and you can formally model paths. And you can look at it in different time steps. So here's an example where the paths become more hierarchical through the time, just as the sites become more hierarchical. So a path that gets more people traveling along it, or more trade along it, encourages more trade. And what you get, which is quite an interesting possibility, is the consolidation not just of sites, higher order sites, but of certain arterial routes in the landscape that map out regionalism. So you get a Western Cretan one, you get an Amari Valley and Brethino sort of Western Mesera link, and you get what Arthur Evans rightly or wrongly would have called the Great South Road between the centre of the north part of the island and the south part of the island. I think there's some problems with this, but the idea of modelling paths and places dynamically together is quite fun because that's sort of the way things often work with routes and places. Okay, last thing I wanted to talk about is different, but it's sort of come back to why I think it's linked in a second, and that is why aren't we leveraging some of the long-term material culture that we have in the Mediterranean and Aegean more for modelling purposes? So what I want to look at is containers, transport containers. There isn't anywhere in the world, I don't think, as long a record of specialised transport containers as there is in the Mediterranean. There have been things that are specialised boxes and jars for moving commodities across the sea in the Mediterranean far, far earlier and in denser numbers thereafter than anywhere else in the world. And it's interesting that even today, there's a denser bundling of container ships through the Mediterranean than anywhere else in the world by a long, long margin. So even though the Mediterranean is maybe not the powerhouse it used to be economically, it's still a conduit for all of this specialised transport. And this is just a picture of 1723, and there is some, in here, there are some specialised jars. Amidst all of the other stuff that's landing on the Marseille docks, jars and bundles and all sorts of things, we've got barrels, by this period, are the key container phenomenon. That sounds a bit sort of descriptive, but you can model some of this stuff formally as well. This is probably where to start, which is that the amphora tradition in the Mediterranean starts really early. Edge of the Mediterranean, you've got jars starting to become specialised end of the 4th millennium in places like Egypt, but more importantly along the Egypto-Levantine coast, where you're starting to get incipient seafaring. You've got these things appearing in the Eastern Mediterranean and getting all the way to the Aegean, certainly Canaanite jars by the Middle and Late Bronze Age. And shipwrecks such as this one in the Aegean. By this point, you've got a whole host of, we think of this as the standard Bronze Age Uluburun style transport jar. The reality is diverse, particularly in the Aegean, where you've got courseware stirrup jars, you've got this other type, which is sort of roughly, I guess, a palace style jar, but coarser, and you've got these big Cypriot pithoi as well. They're all on these ships together as specialised transport jars. Later, you've got this. This is the Western Mediterranean types of amphorae. So from Italy west, so not Aegean. But this is a typology from 100 BC to 600 AD. And you can see that certainly in certain periods, you're just getting vast numbers of these specialised jars of various sorts that are containing different kinds of products, not always a single product, they can be reused, but wines and oils and all that sort of thing. And those show statistical properties that we don't look at very much. We should be looking at from the Bronze Age forward, to do with their shape, their capacity when full, their centre of gravity when manipulated, all of those sorts of things. Later the container culture changes. So in the West, you start getting Romans using Roman use of barrels for military purposes. These are other interesting container types in the Roman period. In the Eastern Mediterranean and Aegean, you get the persistence of amphorae till much later. This is a medieval type from the Northern Aegean Black Sea area particularly. It's quite common elsewhere in the Mediterranean. Venetian barrels. The switchover to barrels is late in the Eastern Mediterranean. We don't really talk about it, but the switchover is very late in the Eastern Mediterranean, much earlier in the Western Mediterranean. You're getting 13th century amphorae is still very common in the Aegean, for example. Here's a modelling exercise just to sort of give you a sense to finish on what I mean by these sorts of opportunities for trying to do something computational and statistical. So a few people have mentioned something odd about amphorae. When they look at, say, amphoras from the island of Chios in the Aegean. That's what it looks like to start with, and model it like this, and there's a clear shape trend, which is that those amphoras get taller. The capacities don't necessarily change, the volumes don't necessarily change, the shapes do. And, I mean, if you like your evolutionary archaeology, you would call that an evolving tradition. If you don't, then you can just call it something else. They're becoming taller through time. And the interesting thing about that is it's not just Chios, and it's not just Thasos, and it's not just a bunch of other islands in the Aegean, that trend models fairly consistently over the period between about 700 BC and 0 across the entire Mediterranean. So this is a really simple measure, the height of the amphora versus the width of the amphora. And this is a way of describing a histogram, if you like, a distribution, but in 2D. And this is the trend in that first period for all amphora types that we know of in the Mediterranean. They all elongate, which is really weird. Like the ones that are being used by people in southern Spain in 500 BC are elongating, while the ones in the Aegean are as well, are totally different types. Which must mean, I'm not really sure, but it's probably got to do something to do with the depth of ship holds, possibly, and the size of ships overall changing through time. Or possibly more priority on wine, which some people say needs a longer amphora, maybe. Or possibly greater potting skill, because it's more difficult to produce a taller amphora, or all three of those. But it demands an explanation, because that's a real trend. Thereafter, things get more messy, but the thing that's quite interesting is you should be able to even view this on a really crude measure like that there are sort of regimes in here, which are called A, B, C, and D, and E, where things look a bit different. And this is an obviously totally different one, where the amphoras from about 650 onwards are squat and small again across the entire Mediterranean, whether you're looking at those around Istanbul, whether you're looking at those by the Guadalquivir. And that needs some modelling as well. I suspect if you looked at other forms of material culture, you might find some interesting pan-Mediterranean issues there as well. The reason I think that, and you can compare it to other data across the same time period, and some of it matches in interesting ways, such as that's Shipwrecks in blue, and this is the summary of the amphora heights and widths. You can see that they're not exactly correlated, but there's some interesting correspondence there in terms of peak periods of activity. So does that mean that more ships, some bigger ships, deeper holds, the amphoras are changing for that reason? I don't know. But it's sort of fun macroeconomic modelling. I think that's sort of linked to the settlement, because here's somebody's model from the 1960s of what happens to settlement under periods of maritime interaction, which is that you get the bundling of settlement into more nucleated forms. And people have argued this in survey in the Aegean as well. So Renfrew and Wagstaff and John Cherry and other people have argued for the islands in the Aegean, finding phases of nucleation of their settlement corresponding with broader geopolitics. So as there's lots of trade, you get some sites nucleating. I think that's attached to the material culture. I said on Antikythera, you get these pulses of variety, of abundance and scarcity in material culture as the broader settlement landscape changes and as interactions change. And I think you can also see it in the amphora record over longer time periods. So I think you can tell a story of settlement dynamics in small regions and on a Mediterranean scale, and not lose sight of the material culture either. So, thanks.